All right, hi, good morning, everyone. We are looking at our next section in our parallel lines and transversals. So we're going to be just reviewing a little bit more about what we talked about last time over naming the angle pairs and whether or not they are congruent or supplementary. So I just wanted to revisit that again a little bit this morning. All right, so let's just look at our names real quick and see kind of what we remember from last week. All right, remember corresponding, these are angles that are in matching positions. Or you can think about it as in matching spots. So it's all about, are they in the top left, top right, bottom left, bottom right? And then we go down to the other intersection and see which one's in the exact same position. Then we also have alternate interior. So remember, alternate meaning opposite. Interior for inside the parallel lines. Then we have alternate exteriors. These were opposite. Exterior for outside. And then we had our two consecutives. Consecutive interior for same side. Meaning same side of the transversal. Again, interior for inside the parallel lines. And our last one, consecutive again for same side. Exterior for outside of the parallel lines. So let's use the picture that's next to this and see if we can find some angle pairs that match these descriptions. All right, so corresponding, again, matching positions. So let's say if I'm looking at angle 1 is in the top left. So if I take that exact same intersection and move it down to the other area, where the other intersection, it matches up exactly with 5. So there's one of our angle pairs. Angles 1 and angle 5. Let's say I try another one. If I'm looking at angle 2, that's in the top right. If I take that same intersection and move it down to the next one, then it lines up exactly with angle 6. So there's another. Angle 2 and angle 6. So again, it's all about the positions and where they're sitting. If I'm looking at angle 4, then it has to match up with angle 8, bottom left with bottom left. So angles 4 and 8. And then our last pair, angle 3 in the bottom right, matching with angle 7, bottom right. Now, when we talk about parallel lines and transversals, some of these were the congruent ones. Some of them were supplementaries. These, again, corresponding ones are congruent. So if I know one measure, I'm going to automatically know the other. So let's move on down to our next pair, just as again reviewing. Alternate interior, so they have to be on opposite sides of the parallel, inside the parallel line. I'm sorry, opposite sides of the transversal, inside the parallels. So remember, all this space in between the parallels is where your interior is. So my numbers need to come from that area. So if I'm looking at angle 4, which is on the left side of the transversal, I need something on the right side, but inside the parallel lines. My only options are 3 and 6, but since 3 is a linear pair with 4, it can't be an alternate interior. So angles 4 and angle 6. Now let's look at the other side of that. What if I did start at angle 3? Well, angle 3 is on the right side, so I need something on the left. That's either 4 or 5, again, inside the parallel lines. But it cannot be angle 4, because again, 3 and 4 are a linear pair. They're neighbors. So it's got to be angle 5. And those are our only two alternate interiors that we have in there. Then we have alternate exteriors. Similar idea, but now we're on the outside of your parallels. So that would be those two areas. Those are our alternate exteriors. I mean, those are our exterior. And we're looking at, let's say we start with angle 1, which is on the left side of the transversal on the outside. So we need something that's on the right side. So that's 2, 3, 6, and 7. Well, 2 is out, it's a linear pair. 3 is out, it's vertical. 6 is out, it's on the interior. 7 is the one that's left. So angles 1. Oops, sorry, writing that in the wrong spot. Angles 1 and 7. And then let's get our last ones up here. Let's say we look on the other side, the 2. 2 is on the right side of my transversal, so I need something on the left. That's 1, 4, 5, and 8. 1 is out because it's already a linear pair. 4 is out because it's a vertical angle. 5 is out because it's interior, not outside. So 8 is the only one I have left. So angle 2. And angle 8. Those are our outside and opposite alternate exteriors. Now let's check out and review just a little bit of the consecutive interiors. So again, consecutive interior, same side of the transversal in between the parallel lines. So let's start with one inside those parallel lines. Let's start with 3. 3 is on the right side of my transversal. I need something that's on the right side as well. So that's 2, 6, and 7. 2 is out because it's a linear pair. 6 is my other option. 7 is out because it's exterior. So 3 and 6. If I was to start with angle 4, I would have to use angle 5. They're both on the left side, and they are both inside the parallel lines. All right, and then our consecutive exteriors. Let's say we start with 2. 2 is on the right side, so that's 3, 6, or 7. 3 is out, it's a linear pair. 6 is out, it's on the interior. 7 is the only one that's left. And then our last ones, let's say this time we start down at angle 8, the other intersection. It's on the left side, so that's 5, 4, and 1. 5 is out, it's a linear pair. 4 is on the inside, so it's out. 1 is left. All right, so those are our different pairs. And again, let's go back and review just a little bit on congruent. We already talked about how corresponding ones were congruent from last week. Alternate interiors was another set that were congruent. And so were alternate exteriors congruent. While the consecutive pairs, those are the ones that were supplementary because they had to add up and be 180 degrees. Now, guys, when it comes down to it and you can't remember whether they're supposed to be congruent or 180, if all else fails, go back and look at the size of these angles. All right, there will be times where your pictures won't be drawn to scale, but you can always go back and make your best judgment. Let's say I'm looking at angle 3 for a second. Angle 3, let's say we were to classify that as acute, right, or obtuse, this would be an acute angle. So it's got to match up with your other acute angles, which would be angles 1, 5, and 7. All the acutes have to match up when your lines are parallels, just like all the obtuse ones have to match up when your lines are parallels. Now that does change a little bit when we come to perpendicular lines, and we'll look more at that at another time. But again, when in doubt, check the sizes of them to kind of be your guide as to which ones are supposed to be congruent or not, or are they supposed to add up to 180. So with that, let's go down and actually just review a little bit on last week, how we've got some numbers here. All right, so in our picture, it tells us that measure of angle 2 is 75. measure of angle 2. Remember that little m stands for measure of. Then we have your angle symbol and 2. So the measure of angle 2 is 75 degrees. Okay, so I can use what I know about my intersections here. So we're going to start just with the top intersection. So guys, pretend 5, 6, 7, 8, not there. You right away have vertical angles, where vertical angles have to be across from each other in the same intersection, which means angle 4 is also 75 degrees. When your angles are neighbors and they complete a straight line, those are the supplementaries, the linear pairs. So angles 2 and 3 are linear, and angles 2 and 1 are linear. Or you could think about it as 1 and 4 linear, 4 and 3 linear. And if they are in fact linear pairs, they should add up to 180. So 180 minus 75, that's 105 left. And since angle 1 is 105, angle 3 is also 105 because it's a linear pair to the 75s and it's vertical to the 105. Now, here's the beauty of corresponding angles and all your other angle pairs. If I know one of these values, I automatically can figure out the other 7. Because angle 2, like we said earlier, angle 2 is corresponding with angle 6 because they're in the exact same position. And since I know they're congruent, I can copy that 75 down. So angle 6 also has to be 75. Now, angles 3, using some of our other relationships here. Angles 3 and 5, alternate interiors. 3 is on the left and inside, 5 is on the right and inside. They also have to match up because alternate interiors are supposed to be congruent as well. Angle 1 could also have a relationship to angle 8 because those were your consecutive exteriors. And we said the consecutive ones are supposed to make 180. So 180 minus 105 puts me back at 75. Angle 1 and angle 7 are alternate exteriors, and they're also supposed to be congruent. So there's lots of different ways that you can use to work your way around these intersections to figure out what are the different measures. So let's use that and answer these questions. All right, so the first one we've got, is the measure of angle 1. Well, angle 1 was supposed to be 105. And then it says angles 1 and 2 form a what? Well, they're in the same intersection and they're neighbors. These were your linear pairs. Angle 3 is also 105 out of our picture. Angles 3 and 6 form a they're on the same side and inside. So these are consecutive interiors. All right, angle 4 on my picture is 75. 4 and 2, forgot my little degree bubbles here. 4 and 2 are vertical angles. Angle 5 is also 105 degrees. 5 and 3, alternate interiors. And let's keep going. Angle 6, we have 75 degrees. 6 and 2, corresponding. Angle 7, back at 105. 7 and 3, corresponding again. They're in matching positions. And then our last one, angle 8, 75. 8 and 1, consecutive exterior. Okay, so you can see that if we know one of those angle values, we can also find the other ones using different parts of those angle pair relationships. But remember, linear pairs and vertical angles happen at the same intersection. All the rest, the alternates, the consecutives, the corresponding, are comparing the two intersections, one from the top with one from the bottom. So knowing that, let's throw some algebra in this and see kind of how we do. So again, you have to make sure you know what is the angle pair and are they supposed to be congruent or should they add up to 180 degrees? So let's see what we've got. Explain the value of the variables in each figure and explain your reasoning. So let's look at this first one example, 2a here. All right, so we've got 3x minus 3 inside the parallel lines on the left side of my transversal. I have 4y plus 4, same side of the transversal and inside. So right now we are looking at consecutive interiors, but problem is one's got an x, one's got a y. I can't use those yet to solve. So let's see if we can go back and use our x again, which is on the left side of your transversal. Look at your 60. It's on the opposite side of the transversal, and these two are inside the parallel lines, which make them alternate interiors. And I know from earlier, alternate interiors are equal. So that's my clue on how I solve these. So these are alternate interiors. And alternate interiors are congruent. So that means your two angles are equal. So 3x minus 3 will equal 60 degrees. And I can use that to solve. So we can add our 3 back. So 3x will equal 63. Now I can divide out by that 3 to isolate my x. And my x is equal to 21. There's my x, my first value. Now we're going to use this information and go from there to figure out what is the relationship and figure out for y. So let's go back to y. All right, so we already said earlier that 3x minus 3 and 4y plus 4 are consecutive interiors, so they should add up and be 180. The other option we have is to use that same 60, because 60 and 4y plus 4, they're at the same intersection and they're neighbors. They are linear pairs. I'm going to go ahead and use that one because I have my 60 degrees there. So 4y plus 4 and our 60 are linear pairs. And they should add up to be 180 degrees, making them supplementary. So 4y plus 4, let me make sure I wrote that right. Yes. First angle plus the second angle should make 180. And let's solve this. So this time we do have some terms that we can combine because a 4 and a 60 give us 64. Should equal 180. And let's keep solving this now. So minus your 64 to both sides to cancel that out, to remove it. 4y is 116. And now we can divide both sides by that 4. And my x is 29. I'm sorry, my y. And y is 29. So now we found, using our relationships, both angles. Let's try another one and see if we can get a different way here. All right, let's look at what we have. So we have 3y minus 1. Now this time, your parallels are going more up and down direction. So just be careful with these because you've got one intersection happening here and your other intersection happening over on the other side to the right. So just be careful because again, our transversal is the one line going the other direction. So let's see how we do for this one. All right, 3y minus 1. Let's just look at its location in relationship to the 40. All right, this is an angle set that we do not have a relationship for. There is not one here, but I do have a relationship with the 5x. Problem is, I can't use those two because they have different variables. I need to use that 40 to solve at least one of them first. And since it doesn't have a relationship with 3y minus 1, it does have a relationship with the 5x. Just like the previous problem, these two are linear pairs. And they are supposed to be 180. So 40, our first angle, plus 5x, the second angle, should make 180. And this I can use to solve. So subtract your 40 to both sides. Oops, sorry, I meant to do that in another color. We're left with we're left with 5x on the left and 140 on the right. And now we can do our division step. Divide both sides by 5. And my missing x, 28. So now I have x. All right, so let's go back to our picture. So again, we know that there is not a relationship between 3y minus 1, that angle, and where your 40 degrees angle are sitting, but we do have a relationship from 3x minus 1 and the 5x. Those two angles are alternate exteriors. And I know alternate exteriors are supposed to be congruent. Oops, didn't mean to zoom in quite that much. Sorry, guys. All right, so now we have alternate exteriors, which like we saw on the other page, these are congruent. So your two angles are supposed to be equal. So 3y minus 1 is supposed to equal 5x. Now, why am I actually using the 5x this time instead of the first time? Well, because now I know what x is supposed to be. So before I can do any of my solving, I need to plug in the 28 we just found. So really, I'm looking at 3y minus 1 equals 5 times 28. Now I have a value there instead of a 5 and an x, a 5 and a variable. So we are looking at 3y minus 1 is supposed to be 5 times 28. That's 140. Now I can solve this. All right, so let's get rid of your subtract here. So add that 1 back to both sides. So 3y will equal 141. Now we can divide both sides by 3. And our y is equal to 141 divided by 3, 47. Now we have our y as well. So sometimes I can't necessarily use ones that I know are congruent to solve. I have to start with what I do know. Where do I have a relationship I can make? Then I can use ones that have two different variables as long as I know what one of them are already. So knowing that, let's try our last pair. All right, this time we don't have any given angle values, just like the last two. But again, I want to see where do I have a relationship that I can go ahead and solve. All right, so if I look at the 8x minus 10 and the 6y plus 20, I don't know what either of the variables are yet, so I can't use those two. But I do have a relationship that I can set up between 8x minus 10 and the 7x. These are alternate interiors, and they're supposed to be congruent, so I can solve that. So alternate interiors, again, they're supposed to be congruent. So 8x minus 10 is supposed to equal 7x. Let's solve. So we're going to add that 10 back. Oh, I'm sorry, not the 10x, not the 10, sorry. We will minus, because again, your goal is to get your variables on one side of the equation, your constants on the other. Now, normally I tell people to cancel the smaller variable first. The problem is I only have a constant, your plain number, on the left. Leave that minus 10 where it is and get your variables on the other side, because the other side doesn't have a constant. So leave that minus 10 where it is, and we're actually going to do a little bit different and get rid of the 8x first. So now we have a negative 10 is equal to a negative 1x. We can divide out that negative 1. And my x is equal to 10. And then your symmetric property says you can reverse that because we tend to like our letters first. It's not a requirement, but we tend to like it. But I wanted you to see how the symmetric property can actually be used here. So again, we can use the symmetric property to flip this over. But either answer, guys, is always going to be correct. All right, so let's check out what we can do now to get our y. Because our 8x minus 10 and our 6y plus 20 are the consecutive interiors. And we know those are supposed to add up to 180. They're supposed to be supplementary. And now that I know what x is, now I can use both of those equations. So we have consecutive interiors, and they're supposed to make 180. They're supposed to be supplementary. So our 8x minus 10, first angle, plus the second one, are supposed to be 180. And like before, we are going to have to plug in the 10 that we just solved for our x. So 8, x was a 10, and then minus 10 plus 6y plus 20 equals 180 degrees. And let's keep solving this. Sorry, that was not very straight at all. There we go. All right, 8 times 10 is an 80. And then we'll take away 10 from that, plus 6y plus 20 equals 180. You've got lots of terms we can combine here. 80 minus 10 is 70, plus another 20 from the end of this is 90. So 90 plus 6y is supposed to be 180. All right, now we can keep going with our solve now that we've cleaned up everything. So minus your 90 from both sides. So 6y is still left, which equals 180 minus 90 is still a 90. Now we can divide both sides by the 6. And our missing y, 15. And now we have all our values. And guys, we've seen how we can use algebra to help solve these pieces as long as we know what your relationship is for your angles. So guys, I hope you enjoyed learning a little bit about how we can use angle pairs to solve out our missing angles. Please don't hesitate to reach out to me if you have any questions at all. Bye, guys.